if I can get the vector template stuff set up and running, then that's like 90% of the stuff. So I don't know, so I'm trying to finish up whatever. A pop a day, or a soda pop a day, that's not gonna keep the dentist away. If anything, it's gonna make the dentist stay. I gotta cut down on the pop.
One zero four five.
At least the sound's still working.
Internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if P is a string.
So I copy pasted
Index B canonical.
because I missed like an if or something.
B if numeric index is not undefined.
I gotta paste it back, and then I'm trying to run it.
Their index O numeric index is false. Return true, else return false 2. Return ordinary delete O P 0 4 5 7. The
All of a sudden,
array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let tar record be capital M
the streaming software has no issues at all.
T Y P E D capital A R R A Y capital W I T H capital B U F
Was something running on my computer in the background?
W I T N E S O sexy S T let keys be in is typed array out of bounds. Tar record is false.
Really weird.
Length tar record B for each integer I such that 0I length in ascending order. Do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to key 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I
I don't know, whatever.
E S takes arguments O B J
Alright, take this on.
sexy ST or unordered and returns a typed array with buffer witness record. It performs the following steps when called let buffer be obj if is detached buffer buffer is true. Then, let byte length be detached, field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. ECMA International 2024 197. 3. Else, let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record, obj, byte length 0, 4, 5, 1 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called let internal slots list be dart. Let A be make basic object, internal slots list. Set A as specified in 1 0, 4, 5, 1. Set A as specified in 1 0, 4, 5, 2. Set A as specified in 1 0, 4, 5, 3. Set A as specified in 1 0, 4, 5, 6. Set A as specified in 1 0, 4, 5, 7. 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called if is typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size 0, 4, 5, 1 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called assert. Is typed array out of bounds, tar record, is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer, O, is false. Let byte offset be O. Let element size be typed array element size, O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length, byte offset, element size 0, 4, 5, 1 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a Boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer, O, is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then A let byte offset end be buffer byte length. Else, A let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1 4 is valid integer index. O, index. The abstract operation is valid int. Edger index takes arguments O, a typed array, and index, a number, and returns a Boolean. It performs the following steps when called if is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true. Return false. Let length be typed array length, tar record. If index 0 or index length, return false. Return true. 0, 4, 5, 1, 5 typed array a get element O index. The abstract operation typed array a get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called if is valid integer index O index is false. Return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be index element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true. Unordered 0, 4, 5, 1, 6 typed array set element O index value. The abstract operation typed array set element takes arguments O, a typed array, index, a number, and value, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called if O is bigint, let num value be. To bigint, value otherwise, let num value be. To number, value if is valid integer index O index is true. Then a let offset be O. B let element size be typed array element size O. C let byte index in buffer be index element size plus offset. D let element type be typed array element type O. E perform set value in buffer O. Byte index in buffer element type num value true. Unordered return unused. ECMA International 2024 199 10 4 5 17 is array buffer view out of bounds O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called if O has their internal slot. Then A let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return is view out of bounds. View record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy S T return is typed array out of bounds. Tar record 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings X ported from an ECMA script module. C16 2 3. There is a one-to-one correspondence between the string keydone properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value done property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. these methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot, type, description, module. A, module record. The module record whose exports this namespace exposes. Exports, a list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort %using a undefined as compare f 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called return null 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer 1 0 4 6 2 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called 1. Return set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called return true 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary get own property O p. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor value true, true, false 0 4 6 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary define own property O p. Desk. Let current be O p. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has a field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value. Desk. Current. Return true 0 4 6 7 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if p is a symbol. Return ordinary has property O p. Let exports be O. If exports contains p, return true, return false. ECMA International 2024 201 10 4 6 8. The if p is a symbol, then a return ordinary get O p. Receiver. Let exports be O. If exports does not contain p, return undefined. Let m be O. Let binding be m resolve export p. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace, target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception 2. Return target env get binding value, binding, true 0 4 6 9. It performs the following steps when called return false 1 0 4 6 1 0 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if P is a symbol, then a return. Ordinary delete. O, P. Let exports be O. If exports contains P, return false. Return true. 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let exports be O. Let symbol keys be ordinary O and property keys. O, return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 10 4 6 12 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let M be make basic object. Internal slots list. Set M's essential internal methods to the definitions specified in 10, 4, 6. Set M to module. Let sorted exports be a list whose elements are the elements of export sorted as if an array of the same values had been sorted using %array prototype sort % using a undefined as compare F. And set M to sorted exports. Create own properties of M corresponding to the definitions in 28.3. Set module to M 0. Return M 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized.
I always forget
Exotic object if it's
the union. Freaking.
Its other essential internal methods may
Not always.
implementation, depending on the specific
But when I miss it,
type exotic object in
or like forget to add union,
7, 1.
I totally miss it. And the compiler does not help at all.
Object O takes argument V. An object or
I gotta like make a note to always remember
containing a boolean or
to check for this first.
it performs
If it like fucks up.
called return set immutable prototype O
Oh, it's like 10 minutes. Dang it.
N to set a mutable prototype O V. The abstract operation set a mutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let current be O if same value V current is true. Return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments, and in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203, slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create table 34. proxy handler methods, internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. 04. Copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, get prototype of if trap is undefined. Then, a return target, let handler proto be. Call, trap, handler, target, if handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible, target, 0. If extensible target is true, return handler proto, 1. Let target proto be target, 2. If same value, handler proto, target proto, is false, throw a type error exception, 3. Return handler proto, 0, 5, 2, V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, set prototype of if trap is undefined. Then, a return target V, let boolean trap result be to boolean. Call, trap, handler, target, V. If boolean trap result is false, return false. Let extensible target be. Is extensible, target, 0. If extensible target is true, return true, 1. Let target proto be target, 2. If same value, V, target proto, is false, throw a type error exception, 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible if trap is undefined. Then A. Return is extensible. Target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception. 0. Return Boolean trap result. 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions if trap is undefined. Then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target B if extensible target is true. Throw a type error exception. Return Boolean trap result. 0, 5, 5, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoked proxy. O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor if trap is undefined. Then a return target P. Let trap result TOBJB. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target P. 0. If trap result obj is undefined, then A. If target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target D. If extensible target is false, throw a type error exception. E returned undefined. 1. Let extensible target be is extensible. Target 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be is compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then A. If target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as a known property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, P. Desk. The internal method of a proxy exotic object O takes arguments P, a property key, and desk. a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, define property if trap is undefined. Then, A return target P, desk, let desco be J be from property descriptor, desk, let boolean trap result be to boolean. Call, trap, handler, target, P, desco be J if boolean trap result is false. Return false, 0. Let target desk be target P, ECMA International 2024 207, 11. Let extensible target be is extensible target 2. If desk has a comma field and desk is false, then a let setting config false be true 13. Else a let setting config false be false 4. If target desk is undefined, then a if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else a if is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, I if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, has if trap is undefined. Then, a return target P, let boolean trap result be to boolean. Call, trap, handler, target, P, if boolean trap result is false. Then, a let target desk be target P, B if target desk is not undefined. Then, I if target desk is false, throw a type error exception. 2. Let extensible target be is extensible target 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08 ECMA International 2024. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The language value and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, get, if trap is undefined. Then, a return target, let trap result be. Call, trap, handler, target, P, receiver, let target desk be target P if target desk is not undefined and target desk is false. Then, A if is data descriptor, target desk, is true and target desk is false. Then, I if same value, trap result, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true and target desk, 0. Return trap result. Note, The value reported for a property must be the same as the value of the corresponding target object property if the target object property is an unwritable, non-configurable owned data property. The value reported for a property must be undefined if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. A. If is data descriptor, target desk, is true and target desk is false, then I if same value. V. Target desk, is false. Throw a type error exception. B. If is accessor descriptor, target desk, is true, then I if target desk, 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is an unwritable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property if trap is undefined. Then a return target P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, return false. Let target desk be target P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do A. Let desk be target key. B. If desk is not undefined and desk is false, then I append key to target non-configurable keys. See else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let you check result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note: for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This argument, arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then A. Return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Array. Note: a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211, the 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: perform. Validate non-revoked proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then A. Return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note: 2. For proxy object CNF says the following invariants. The result of must be an object. 0, 5, 1, 4. Validate non-revoked proxy. Proxy. The abstract operation validate non-revoked proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called: if proxy is null, throw a type error exception. Assert. Proxy is not null, return unused. 0, 5, 1, 5. Proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called: if target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let PB make basic object. Set P's essential internal methods, except for and, to the definitions specified in 10.5. If is callable. Target is true. Then, A. Set P is specified in the 10th of May 2012. B. If is constructor. Target is true. Then, I set P is specified in the 10th of May 2013. Set P to target. Set P to handler. Return P. 12. ECMA International 2024. Note: 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMA script language. Source text. 1.1 Source text syntax. source character. Any Unicode code point. ECMA script source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation process is the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals, and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively not as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000A, for example, occurs within a single line comment, it is interpreted as a line terminator Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA script program, the Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point. CP, the abstract operation UTF-16 encode code point takes argument CP, the Unicode code point, and returns a string. It performs the following steps when called assert. 0 CP0x10FF. If CP0xFF, return the string value consisting of the code unit whose numeric value is CP. Let Q1 be the code unit whose numeric value is floor. CP0x10,000, 0x400, plus 0xD800. Let Q2 be the code unit whose numeric value is CP0x10,000, modulo 0x400, plus 0xDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string, text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics. UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead, a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xD800, 0x400 plus, trail 0xDC00, plus 0x10,000. Return the code point CP. 1 4 static semantics. Code point at string position. The abstract operation code point it takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string ng as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If first is neither a leading surrogate nor a trailing surrogate, then A return the record CP 1 false 6. If first is a trailing surrogate or position plus 1 equals size, then A return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then A return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point. First, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string position. B append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note 2, see also Clause 17. 1.2 Types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. Script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots. See 10.2 of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any, of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the body S of function definitions. 15.2. Arrow function definitions. 15.3. Method definitions. 15.4. Generator function definitions. 15.5. Async function definitions. 15.8. Async generator function definitions. 15.6. And async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7, 1, 1. Note to the practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2, 2 strict mode code. An ECMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prolog that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors as strict mode code if the last argument is a string that when processed is a function body that begins with a directive prolog that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prolog are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prolog. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prolog an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 1, 2, 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined within ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or EGXP goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: A equals B high G exec, CMAP, D, where the first non-white space, non-comment code point after a line terminator is U plus 002F, Solidus, and the syntactic context allows division or division assignment, no semicolon is inserted at the line term in eta. That is, the above example is interpreted in the same way as A equals B high G exec, CMAP, D, syntax, input element div, white space, line terminator comment common token div punctuator right brace punctuator, input element regexp, white space, line terminator comment common token right brace punctuator regular expression literal. ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator, comment, common token, regular expression, literal, template, substitution tail, input element, template tail, white space, line terminator, comment, common token, div, punctuated, template, substitution tail, input element, hashbang, or exp, white space, line terminator, comment, common token, hashbang, comment, regular expression, literal. 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database, such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals, U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U plus FF, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWNBSP. Characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMA script source text, ZWNBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space. White space code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, note 1 U plus 0020, space, and U plus 00A0, no break space, code points are part of USP syntax. Note 2 other than for the code points listed in Table 36. ECMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator, ZEDS. 2.3 white space, tab, VT, FF, ZWNBSP, USP. Line terminators. Like white space code points, line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF, and CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point, Unicode name, abbreviation, U+000A, line feed, LF, U+000D, carriage, return CR, U+2028, line separator, LS, U+2029, paragraph separator, PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CR, LS, PS, line terminator sequence, LF, CR, look ahead, LF, LS, PS, CR, LF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest. Because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the arc to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax, comment, multi-line comment, single-line comment. 20. ECMA International 2024. Multi-line comment chars opt, multi-line comment chars, multi-line not asterisk char, multi-line comment chars opt, post asterisk comment chars opt, post asterisk comment chars. Capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E. Multi-line comment chars opt, post asterisk comment chars opt, multi-line not asterisk char, source character but not, capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E. Source character but not one of or. Single line comment chars opt, single line comment chars, single line comment char, single line comment chars opt, single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax, hashbang comment, single line comment chars opt, 2.6 token syntax, comment token, identifier name, private identifier punctuator, numeric literal string literal template. Note the div punctuator, regular expression literal, right brace punctuator, and template substitution. Tail productions derive additional tokens that are not included in the common token production. ECMA International 2024-221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points in the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMA script implementations. ECMA script implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier name, identifier start, identifier name, identifier part, identifier start, identifier start char, Unicode escapes, sequence, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, ASCII letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not Gustavixes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 1.2.9.4. Note 1. This standard specifies specific code point additions. U plus 0024, $, and U plus 005F. Low line are permitted anywhere in an identifier name, and the code points U plus 200C, 0 with non-joiner, and U plus 200D, 0 with joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note to the non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each a Unicode escape sequence, they are represented by the exact same sequence.
I never realized.
7. 1 static. Early errors. Identify
That was a void pointer.
escape sequence. It is
You don't have to cast it. Oh my god. You can just assign it.
Unicode code point.
Why did I not know that? Oh my god.
Identifier part. Unicode escape sequence.
I wasted so much time casting things
Sequence is not some Unicode
from Windows API calls
lexical grammar production.
that took void
7. 1.
when I didn't have to cast it.
Identify
Oh my god.
directed operation
This runs fine.
no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name.
You don't have to cast void if it's assigned to another pointer.
Turn CP. Identifier name. Identifier
I wish I knew that 7 years ago.
code points of the derived identifier name. Let CP be identified.
I did notice people assigning
Return the list concatenate.
things like that without casting it sometimes.
7. 1. 3 static
And I never bothered to look. I figured it out.
code point. The syntax an identifier code point takes no arguments.
Oh, that's why. Dang it.
Find piecewise over the following productions. Identifier start. Identifier
Well, now I know.
point matched by identifier start char.
Now I'm just gonna make everything a void pointer.
Unicode properties.
'Cause that's amazing.
Continue include
You don't have to cast it. Oh my god, it's a genius.
ID start and other ID continue. ECMA internet.
Saves so much time.
4223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the MV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the MV of code point. 2. 7. To keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally in a fixed width font. In some syntactic production, the keywords of VCMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts if and while a reserved word's await is reserved only inside async functions and modules async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names, those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield, those that are contextually allowed as identifiers, namely await and yield, those that are contextually disallowed as identifiers, in strict mode code, let, static, implements, interface, package, private, protected, and public, those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meter, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax, reserved word. 1 of await break case catch class const continue debugger default delete do else enmx port extends false finally for function if import an instantia new null return super switch this throw true try type off bar void while with yield. 24 ECMA International 2024 Note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point in a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else you. 65. The early error rules in 1.3. 1 rule out identifiers with the same string value as a reserved word. Note 2enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 Punctuators syntax. Punctuator, optional chaining punctuator. Other punctuator, optional chaining punctuator. Look ahead decimal digit. Other punctuator. 1 of, comma, equals plus percent plus plus. And equals plus equals 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 percent equals 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 and equals 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 and equals 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 div punctuator equals sign right brace punctuator 2.9 literals 2 9 1 null literal syntax null literal null ECMA International 2024 225 1 2 9 2 Boolean literal syntax Boolean literal true false 2 9 3 numeric literal syntax numeric literal separator numeric literal decimal big integer literal non-decimal integer literal plus sep non-decimal integer literal plus sep big int literal suffix legacy octal integer literal decimal big integer literal 0 big int literal suffix non-zero digit decimal digits plus sep up begin literal suffix non-zero digit numeric literal separator decimal digits plus sep begin literal suffix non-decimal integer literal sep binary integer literal sep octal integer literal sep hex integer literal sep big int literal suffix n decimal integer literal plus sep non-octal decimal integer literal decimal digits sep decimal digit sep decimal digit plus sep decimal digits plus sep numeric literal separator decimal digit 1 of 0 1 2 3 4 5 6 7 8 9 26 ECMA International 2024 non-zero digit 1 of 123,456,789 exponent part sep exponent indicator signed integer sep exponent indicator 1 of VE signed integer sep decimal digit sep decimal digit sep decimal digit sep binary integer literal sep 0b binary digit sep 0b binary digit sep binary digits sep binary dig it's binary digit sep binary digit plus sep binary digits plus sep numeric literal separator binary digit 1 of 0 1 octal integer literal sep 0 octal digit sep 0 octal digit sep octal digits sep octal digit sep octal digit plus sep octal digits plus sep numeric literal separator octal digit legacy octal integer literal 0 octal digit legacy octal integer literal octal digit non-octal decimal integer literal 0 non-octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit non-octal decimal integer literal decimal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L 0 octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit 1 of 1,234,567 non-octal digit 1 of 89 ECMA International 2024 227 hex integer literal sep 0x hex digit sep 0x hex digit sep hex digits sep hex digit sep hex digit plus sep hex digits plus sep numeric literal separator hex digit 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCD F A B C D E F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics. Early errors. Numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy. 2, 9, 3, 2 static semantics. MV. A numeric literal stands for a value of the number type or the begin type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digits is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer, decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the two input elements 3 and in. Legacy octal escape sequence. 0 or of binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the MV of decimal digit. 8 or of non-zero digit, the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. EOR of hex digit. E is 14, the MV of hex digit. FOR of hex digit. F is 15, the MV of binary digits. Binary digits binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separated binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digits is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal int J literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digit 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digit 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a begint. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round MV result. MV of decimal literal. Numeric literal, non-decimal integer literal, return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal begint literal suffix. Return the begint value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 begint literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit begint literal suffix 1. Return the begint value for the MV of non-zero digit decimal big integer literal, non-zero digit decimal digits begint literal suffix, non-zero digit numeric literal separated decimal digits begint literal suffix. Let n be the number of code points in decimal digits. excluding all occurrences of numeric literal separator. Let MV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV, 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000A, line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character-sopt, single string character-sopt, double string characters, double string character, double string character-sopt, single string characters, single string character, single string character-sopt, double string character, source character but not one of or all line terminator. LS, PS, escape sequence, line continuation, single string character, source character but not one of or all line terminator. LS, PS, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024, escape sequence, character ESCA, pay sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1, 2, 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1, ECMA International 2024 231. Note 2, LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000A. 2, 9, 4, 1 static semantics. Early errors. Escape sequence. Legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code, this syntax is legacy. 2, 9, 4, 2 static semantics. SV. The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below, or in 1293. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters. Double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters. Single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS, is the string value consisting of the code unit 0x2028 line separator. The SV of double string character PS is the string value consisting of the code unit 0x2029 paragraph separator. The SV of double string character line continuation is the empty string. The SV of singles string character source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character LS is the string value consisting of the code unit 0x2028 line separator. The SV of single string character PS is the string value consisting of the code unit 0x2029 paragraph separator. The SV of single string character line continuation is the empty string. The SV of escape sequence 0 is the string value consisting of the code unit 0x0000 null. The SV of character escape sequence single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2. It is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence, code unit value, Unicode character name, symbol B0x0008, backspace, BS, T0x00009, character tabulation, HT, N0x000A, line feed, LF, V0x000B, line tabulation, VT, F0x000C, form feed, FF, R0x000D, carriage return CR, double quote, 0x0022, quotation mark, apostrophe, 0x0027, apostrophe, backslash, 0x005C, reverse solidus, comma the SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the MV of legacy octal escape sequence. The SV of non-octal decimal escape sequence 8 is the string value consisting of the code unit 0x0038, digit 8. The SV of non-octal decimal escape sequence 9 is the string value consisting of the code unit 0x0039, digit 9. The SV of hex escape sequence X hex digit is the string value consisting of the code unit whose numeric value is the MV of hex escape sequence. The SV of hex 4 digits hex digit is the string value consisting of the code unit whose numeric value is the MV of hex 4 digits. The SV of Unicode escape sequence U code point is the result of performing UTF-16 encode code point on the MV of code point. The SV of template escape sequence 0 is the string value consisting of the code unit 0x0000 null 12 9 4 3 static semantics MV. The MV of legacy octal escape sequence 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits, hex digit is 0x1000 the MV of the first hex digit, plus 0x100 the MV of the second hex digit, plus 0x10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2.2.1 An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular.
Is this like a joke?
Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or.
Chatbot said,
E, G,
let's output the code.
A, R, capital
Compare two small loops,
P, R,
one with restrict, plus const.
N, capital
And it shows the assembly and whatever.
S,
So here's the assembly.
S, H,
Restrict only whatever, and then restrict const.
regular expression class.
And right here it says,
R, regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R,
this is every iteration, load from source,
E,
store to destination,
I, O,
increment, compare jump.
A,
Compiler has to assume destination source might alias outside of the restricted
E,
guarantee for writes,
regular expression
so it reloads.
R,
Source each time, okay?
A, R, capital E, X,
So chatbot's comparing this code to this code.
I,
Restrict plus const.
B, A,
And since this should be more optimal,
S, H,
chatbot doesn't even look or evaluate the code.
regular
It just goes, it's more optimal.
non-terminator,
When it's the same exact thing.
regular
It's the same exact instructions. Exactly the same.
chars, empty, regular expression class,
Differences and benefits.
char, regular
Const restrict tells the compiler source memory will never be modified through another pointer.
capital R,
Safe to keep source values in registers longer forever.
R,
Yeah, longer forever.
X, P, R, E,
It ends up being the same code
I, O, N,
that it gives me. So nothing's held longer forever.
S, L, A, F,
It's the same code. It does the same loads.
E, Q.
It says fewer reloads if the loop is unrolled.
Literal is an input element.
Compiler may unroll loop safely.
22 point
For 4 times unrolled, can do 64 bytes per iteration instead of 16 bytes.
to regular expression objects that never compare as equals to each other.
That's
Literals contents are identical. A
Chap- Chap-
object may also
Chatbot doesn't know what it's talking about.
new regexp
Reduces dependencies
deconstruct
and allows better instructions. Scheduling, improving throughput slightly.
National 2024 regular expression flags.
Restrict only 70 to 80% peak. Notes, reloads every 16 bytes.
The syntax directed
Restrict const 90 to 100% peak.
in source text.
Fewer reloads. Safer unroll. Factorization.
Regular expression
Unroll plus restrict plus const.
flags. Return
90-95 100% peak.
body 1
Best for small, medium arrays.
2 static semantics. Flag
Absolute difference. 10 to 20% faster. Larger loops.
and returns source text.
Takeaways.
Wise over the fold.
Gives the compiler more aliasing guarantees. Better scheduling. Potential unrolling.
Flag.
especially with SAMD.
that was recognized.
For version 87, the benefit is small but measurable.
6. Template literal lexical components. Syntax. Template. No substitution template. Template head no substitution.
So if I add 20% for SAMD instructions
$sign. Templates.
plus
Template middle. Template tail. Template middle.
35%
Sign. Template tail.
for control flow,
Sop template character.
that puts me at like 55%
Sopt.
faster than Chrome.
Expression literals may not be empty. In
When you add up all the things that Chrome doesn't do,
sequence starts a single line comment. To
Chrome misses so much performance.
Commandant. ECMA International 2024 235. Template character. Look ahead. Template escape sequence.
So here's what chatbot said.
Line continuation.
Chatbot said
To sequence. Source character but not one of.
there's an absolute difference in the code.
Template escape sequence. Character escape sequence. Look ahead.
10 to 20%.
Sequence Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit.
But look at the code.
Look ahead hex digit. X hex digit. Look ahead hex digit. U
It literally says copy loop restrict,
hex digit. Look ahead hex digit.
copy loop restrict, const,
U hex digit. Hex digit. Hex digit.
copy loop restrict. You see how like it's a different whatever?
U not code point. Look ahead hex
So chatbot, check the code, said it's different.
hex digit. Look ahead not code point. Hex digit.
Are the people at Mead, chatbot,
FMV of hex
do they not know how to compare two strings?
digits.
They're exactly the same.
V of hex digits 0x10ff. Note template substitution tailors used by the input.
I'll do control F here.
Goal 1 2 9 6 1 static semantics. TV. The syntax directed operation TV takes no arguments and returns a string or
So it shows up here,
a template literal
shows up there.
interpreted by TV as a value of the string type. TV is used to
Do this line,
components of a template object, colloquially
shows up here.
use. In TV,
Oh my goodness.
are replaced by the UTF-6
But somehow the second one is 20% faster.
point represented by the escape sequence. The TV
Oh, it shows up here too.
is the empty string. The TV of template head, $sign, is the empty string. The TV
Oh, what about on this side?
is the empty string. The TV of template tail is the empty string. The TV of template characters. Template characters is undefined if the TV of template character is undefined.
That's the difference. A single increment.
Otherwise, it is the
Why does the compiler
character and the TV of template
need restrict and const?
of template character, source character but not one of or $sign or line terminator is the
To know that it needs to like not increment,
matched by source character. The TV of template
but do add plus one.
is the string value consisting of the code unit 0x
This is actually faster doing the add plus one.
of template character,
But why does it need to be const?
template escape sequence. The
Increment, add.
not escape sequence is
They both involve adding one.
line terminator sequence is the TRV of line terminator sequence.
Is the compiler just intentionally putting out better code
More international
just because of the existence
TV
of const?
of line terminator
It has nothing to actually do with it being const.
6
Just the fact that const is there.
TRV
The compiler's like, I'm going to use some add instructions instead of increment
string. A template
to optimize this thing.
by TRV as a value of the string type. TRV is used to construct the raw
Yeah, the modern compiler is garbage.
the template raw values. TRV is similar to TV with the difference being that in TRV,
I'm so glad Chrome is written off of C++.
V of no substitution,
So happy.
the empty string, the TRV of template head, $sign, is the empty
Makes it so much easier
of template
to compete with.
string, the TRV of template tail, is the empty string, the TRV of template characters. Template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character $sign is the string value consisting of the code unit 0x0024 $sign. The TRV of template character template escape sequence is the string concatenation of the code unit 0x005C reverse solidus, and the TRV of template escape sequence, the TRV of template character not escape sequence is the string concatenation of the code unit 0x005C reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence 0 is the string value consisting of the code unit 0x0030 digit 0. The TRV of not escape sequence 0 decimal digit is the string concatenation of the code unit 0x0030 digit 0, and the TRV of decimal digit, the TRV of not escape sequence x look ahead hex digit is the string value consisting of the code unit 0x0078 Latin small letter x, the TRV of not escape sequence x hex digit look ahead hex digit is the string concatenation of the code unit 0x0078 Latin small letter x, and the TRV of hex digit, the TRV of not esca pay sequence u look ahead hex digit look ahead is the string value consisting of the code unit 0x0075 Latin small letter u, the TRV of not escape sequence u hex digit look ahead hex digit is the string concatenation of the code unit 0x0075 Latin small letter u, and the TRV of hex digit, the TRV of not escape sequence u hex digit look ahead hex digit is the string concatenation of the code unit 0x0075 Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence u hex digit look ahead hex digit is the string concatenation of the code unit 0x0075 Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence u look ahead hex digit is the string concatenation of the code unit 0x0075 Latin small letter u, and the code unit 0x007b left curly bracket, the TRV of not escape sequence u not code point look ahead hex digit is the string concatenation of the code unit 0x0075 Latin small letter u, the code unit 0x007b left curly bracket, and the TRV of not code point, the TRV of not escape sequence u code point look ahead hex digit look ahead is the string concatenation of the code unit 0x0075 Latin small letter u, the code unit 0x007b left curly bracket, and the TRV of code point, the TRV of decimal digit 1 of 0 1 2 3 4 5 6 7 8 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence non-escape character is the SV of non-escape character. The TRV of single escape character 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence x hex digit is the string concatenation of the code unit 0x0078 Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence U hex 4 digits is the string concatenation of the code unit 0x0075 Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence u code point is the string concatenation of the code unit 0x0075 Latin small letter u, the code unit 0x007b left curly bracket. The TRV of ECMA International 2024 237 code point, and the code unit 0x007d right curly bracket. The TRV of hex 4 digits Hexdigit, 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 hexdigit is the string concatenation of the TRV of the first hexdigit, the TRV of the second hexdigit, the TRV of the third hexdigit, and the TRV of the fourth hexdigit, the TRV of hexdigits. Hexdigits. Hexdigit is the string concatenation of the TRV of hexdigits and the TRV of hexdigit, the TRV of hexdigit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 A B C D E F. A B C D E F is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence, LF, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0x2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0x2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0x000A line feed. 2.10 automatic semicolon insertion. Most DCMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is parsed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be parsed as the terminating semicolon of a do-while statement. 1.4.7.2 When, as the source text is parsed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is parsed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normally ed to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38. ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be parsed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement. C14.7.4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. ++ left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue, continue. No line terminator here. Label identifier yield await. Break statement, yield, await. Break, break. No line terminator here. label identifier yield await, return statement, yield, await, return, no line terminator here, expression, plus in yield await, throw statement, yield, await, throw, no line terminator here, expression, plus in yield await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await, arrow function, in, yield, await, arrow parameters yield await, no line terminator here, equals, concise body in, async function declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, yield, plus await, async function body, plus default, async, no line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async, no line terminator here, function binding identifier, yield, plus await, opt, formal parameters, yield, plus await, async function body, async method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async, no line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async, no line terminator here, function binding identifier, plus yield, plus await, opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, no line terminator here, equals, async concise body in, ECMA International 2024 239, async arrowhead, async, no line terminator here, arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a ++ token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the ++ token, then a semicolon is automatically inserted before the ++ token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter, s, are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is, a postfix ++ operator should be on the same line as its operand, an expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2. 1, 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source. 12. 3. Is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source. 1, 2. 3 is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source. 4. A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source. Return A plus B is transformed by automatic semicolon insertion into the following. Return A plus B. The source. A equals B plus C is transformed by automatic semicolon insertion into the following. A equals B plus C. The source. If B else C equals D is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be parsed as an empty statement. The source. A equals B plus C. D plus C print is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call. A equals B plus C. D plus C print, in the circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2. 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus. ECMA International 2024 241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2. 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tagged template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator, for example if the regexp has flags. 2. 1, 0. 3. 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text
So, I don't know.
optional operand. The
After I get like arts links installed,
no line terminator.
I'll deal with
EMA script 2.1.0.3.2. 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions. 15.8 with relation to function definitions.
where are they?
More international.
The SAMD instructions, whatever.
ECMA script language. Expressions. 3.1 identifiers syntax. Identifier reference. Yield.
But I'm pretty sure
Yield.
that these are easier in assembly language,
Yield.
not in C language,
Yield await. Label.
because C sucks.
Yield. Await. Identifier. Yield. Await. Identifier. Identifier name but not reserved word. 3. 1.
Alright, so I'm just gonna keep it simple for now.
Binding identifier.
And do a normal loop.
Tax error if the source
Later on,
contained in strict mode code and
I'd like to figure all this out.
fire is either
And
identifier reference. Yield binding identifier. Yield label
are the same registers behind the scenes used
error if the source text matched
for these instruction sets?
in strict mode code.
Like, could I mix
Await
SSE2 and AVX
identifier. Await.
to copy like twice the data?
Syntactic grammar is module. Binding identifier. Yield.
To like do like
It is a syntax error if this
move memory
parameter by
and whatever AVX is.
wait.
Just make up it up.
2000 and
So like pretending that this is AVX.
binding identifier in the
Let's put AVX here.
with static note.
Pretending that's AVX.
Prohibit automatic semicolon insertion in
With this,
await 0, comma. It is a syntax error if this production has an await parameter identifier reference. Yield await identifier binding identifier
so that way it does
await identifier label identifier
an SMD load,
identifier
then SMD write,
this production
but between it and AVX, load and write too.
identifier as yield. It is a syntax error if this production has an
Would that be like 4 times faster or 2 times faster?
fire as await
Or does the CPU use the same resources?
but not reserved.
So it wouldn't be any faster, probably slower.
This phrase is contained in strict mode code and the string value of identifier name
Because there's like a whole bunch of like layers.
package private
Then I could like stack SSE2
yield. It is a syntax
and SSE1, SSE4,
syntactic grammar is modulant.
and just do a shitload of moving data.
Name is await.
I doubt that works though.
String
I'm not sure about it.
by a
Then I'm done with like checking this.
reserved word except for ye, ld or await. 3. 1. 2 static semantics. String value. The syntax directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name, identifier start, identifier name, identifier part. Let text unescaped be identifier code points of identifier name, return code points to string. Text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier, identifier name but not reserved word, return the string value of identifier name, private identifier, identifier name, return the string concatenation of 0x0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 13 3 Runtime Semantics. Evaluation.
Wrong screen.
Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. yield, identifier reference, await, return, resolve binding, await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax, primary expression, yield, await. This, identifier reference yield await, literal, array literal yield await, object
So like this is SAMD.
expression, class expression yield await,
Oh, no, it's on the wrong screen.
expression,
Explain it again really quick.
expression literal, temp,
So I'm wondering is if
capital,
I stack together or like group up
capital, P, A, R,
AVX after it.
T, H,
So like if these were AVX,
E, D,
the 512 byte,
X, P, R,
and these are the SMD, the 128 byte.
O, N, capital A, N, yield await, capital C, O,
Would it be faster to like group an SAMD load
T, H, E, S, I, Z, E, D, capital E,
with the AVX load and then SAMD store
I, O,
with AVX store?
capital A, N,
Save it back to memory.
expression, plus in yield await, expression, plus
Or would I have to do like
dot, binding I,
the bigger size, transfer outside,
yield await, expression, plus in yield,
and then do the smaller. Oh wait, that's backwards.
expression, plus in yield await, binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as
Or would like
evaluating the identifier reference resolve.
doing the bigger operations like 512 byte
Early error restriction ensures
on the outside be faster.
non-strict code. ECMA International 2024 240
By doing the smaller ones on the inside.
tax when
Or do they use the same resources
expression yield
so it doesn't make a difference?
capital C O V E
Which is what I would assume.
capital P A R E
Because I haven't seen anyone do this online,
S I
so there's probably no benefit.
E X
But if there is,
E S S
I don't know, message chatbot. I gotta get done
capital A.
and check this up later.
The interpretation of capital C
There it says, now we're talking about mixing different vector widths in the same code. Let's unpack it carefully.
T
SSE2 128-bit,
I
AVX 256-bit,
E capital E X P R E
backwards compatible lower 128-bit.
O N
Oh, it's the same thing.
is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await. 3, 2,
So, version i7, no AVX, only SSE2.
semanti, CS, evaluation, primary
That's why Sandy Bridge was a big deal with Mac. When Mac had i7. Now they don't.
1 for identifier reference 1 3, 2, 3. Syntax, literal, null literal, boolean literal.
Each YM instruction can handle 256 bits at once.
1 runtime semantics, evaluation, literal, null literal 1. Return null literal, boolean literal. If boolean literal is the token false, return false. If boolean
Hypothetical.
return true, literal, numeric literal. Return the numeric value of numeric literal.
Yeah, that's what I'm asking.
2, 9, 3. Literal,
Doing like that and then that.
the SV of string literal is
And Chepa says,
9, 4, 2, 46. ECMA International 2024 1, 3, 2, for array initializer. Array elements may be
AVX use wider ports, can execute and carry instructions for the same data.
in the element list
SSE
assignment expression.
on XMM registers still use the same hardware units,
Sing array element
but only half width.
the array and increases the index of
If you alternate SSE AVX type loops,
not defined
you may pollute the registers.
at the end of an array. That
AVX writes to YMM0 extend.
array literal yield await elision not
Wait, it can 0 extend
await
the lower bytes? That's weird.
await elision not assignment expression plus in yield await elision not spread element yield await
insert effects, legacy,
not dis
transition penalties,
in yield await, element list,
on EPX strips.
elision not spread element yield await, elision, spread element,
Man, the CPU is so fake.
assignment expression, plus in yield await, 1 3 2 4 1 runtime semantics, array accumulation, the syntax directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform.
Alright, what about
Array. Length. Len. True. Note. The above step throws if len
general purpose registers?
return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value, init result. Perform.
So we said, what about mixing general purpose registers between SMD instructions?
Value. Return next index plus 1. Note an array literally is an expression
Saying you're talking about general purpose registers
using a list.
interleaved
Expressions.
with SMD instructions.
Include
This is a different story.
the elements needed
How SMD use registers.
each time the array initial.
Oh, that's it.
ECMA International 2024
The stack.
element list.
The freaking call return jump buffer, whatever.
A set next in
Chatbot said,
accumulation of elision with arguments array and next index.
what was it exactly?
Array accumulation of spread element with argument.
It said the branch target buffer
Element list.
for call returns on the call stack,
Expression. Set
that it's highly optimized.
element list with arguments array and next index.
When it's talking about branching,
Then a set next index to
and it lied because it's not optimized. They try to optimize it, but it sucks.
B. Evaluation of assignment expression. Let init value be. Get value, init result.
MS Chatbot,
Create data prop.
did Intel originally use
Next index.
the XMMs or whatever
Plus 1. Element list. Elision not
for call stack returns?
array accumulation of element list with arguments array and next index. If elision is present, then a set next index to array accumulation of elision with arguments array and next index 3. Return array accumulation of spread element with arguments array and next index. Spread element. Assignment express.
Because there's something we gotta like,
Evaluation of
you like warm up the registers or something.
spread ref.
Or it's something really stupid
Get it.
where clearly there's some copy going on behind the scenes. And then they let you use them. It says no in the usual sense. Huh. Maybe it was the x87. I think it's x87. the x87 was like an add-on chip. It's like a bunch of them. And they like switch them around. Except Intel at one point, I think they still might, they used that CPU for pushing the call stack to return from, because it's faster than putting it on the actual stack, because it's in a register on the coprocessor or something like that. There we go. This is, yes, exactly. You're thinking of x87. Floating point unit introduced in the 1980s for 8087 coprocessor and later integrated into CPUs. Floating point, not integer arithmetic. Uses its own 8 register stack. So Intel like took the freaking thing and like used it for something completely different. It's just stupid. So top of stack, stack 1, 7, whatever. Instructions that push pop semantics, FLD, FSTP, etc. Return from floating point functions was often done via ST0. So in effect, x87 had stack-based register return. How x87 relates to call stack returns. Integer pointer returns still via EAX, RAX. Wait, what? Oh. Wait, can I use it then? Alright, so I'm not gonna argue with chatbot, it's not worth it. There's something about, right here it says, it really clarifies why XMM replaced x87 for fast returns. Alright, now chatbot's making me second guess myself. what that was called. That was it. This was not using X, MM, or X87 for stack. They experimented with return address stack or branch check buffer, small hardware buffers, blah blah blah. The RAS stores return address in a fast, dedicated hardware structure, not in general purpose or SIMD registers. Okay, so I guess it's separate registers. Okay, what about interleaving SIMD and general purpose? Chatbot intentionally missed what I was asking. This isn't correct, I'm just making up pseudocode. You can't even do this in C. I think you can get like 7 reads and writes at a time. Not the like 8, but 7. asking chatbot, or what I want to ask it, if you mix the SIMD with the freaking general purpose, will it be faster? It says you're asking about mixing general purpose as temporary transfer storage for areas. Basically using GPR to help pipeline SMB operations. If you could, then even though this is a first gen i7, this is like a first gen i7. I could squeeze out every teensy little bit of performance. Every little bit. I could also use the freaking 8705 chip too. Because it's a coprocessor. So anything it does is additive. It doesn't take away from the main bus, the main pipeline. So if I can find any teensy bit of work, I just got a bunch of ideas. That'd be awesome. I got like a bunch of clever ideas now. And I gotta like test them all. That's great. I need to get on track. It says you load 128-bit chunks from memory. You then scatter portions into GPR. Finally use GPR as an offset. What? No. For God's sake. It says, I got it. You're talking about literally moving SIMD. For fuck's sake. Is this a joke? think it gets me. It says you have SMD units moving chunks of memory via XX, M, and YMM registers. Separately, GPRs are used to move another 64-bit chunk of memory at the same time. The goal increases throughput by using both execution resources simultaneously without one yes depending on the other. How this works in x86. Load store ports vector execution units. GPR executes move. Uses integer ALU load store ports. Can proceed in parallel with SMD, assuming no dependency. Result, both pipelines are kept busy. Oh my god. CPU can execute vector moves and scalar moves simultaneously. This can improve throughput if memory bandwidth is sufficient and loop is unrolled enough. Important caveats, memory bandwidth. If memory subsystem is saturated, extra GPR will help. Early Intel CPUs have separate integer and SMD load ports, so parallelism is possible. Loop unrolling, needing to feed enough independent instructions to both SMD and GPR pipelines. No aliasing, as long as GPR moves and SMD loads store target different memory regions, they won't stall each other. Key takeaway, using GPR in parallel with SMD for different memory regions is a valid optimization. This does not interfere with SMD lanes. So what? SMD is like a coprocessor, like the 8087, or whatever the fuck it was. On a CPU like first Gen 7, you can achieve higher throughput if the memory system can feed both pipelines simultaneously. Essentially, you're exploiting dual pipelines, integer versus SMD. If you want, I can draw diagrams showing SMD. First GPR pipelines operating on separate memory regions in parallel, and how the first Gen i7 could execute both at the same time. This makes it very clear why your approach can improve throughput. I'm going to benchmark it. Wow, it's an amazing diagram. I could do better than that. I could. I really could. Yes, I could. Chatbot's diagram is crap. It's poop. This is what a diagram looks like. This is a diagram. This is a lame attempt, an artificial intelligence attempt to make a diagram. This is a diagram. Why am I wasting time in C language? I gotta get this done. I still gotta convert this all to ARM at some point. That'll be fun. need to output this. Template doesn't get it. I'll test it later. I feel like try to focus. It's like this. This has to be fake. It's not a real freaking test. I would think it'd be faster than that. Literally 1, 2, 3, 4, 5, 6. Yeah, it's not around timing. Okay, I'll check that later. There's like so many things I can do. Squeeze out a teeny bit, and then I tie that. I'm not gonna say whatever. I gotta get the stupid shader program done, so we can work on things. Without showing them on screen. Yeah, and I think I need the header for this stuff. So I'm gonna do later. And super straight goes on the other side of the pointer. There we go. Finally. One more question. So far so good. Enters here. I think the allocation's fine. I gotta get the copy loop set up. Call this thing one more time. Make sure it does the copy. I can actually pass in data to like set to it. And I gotta set up the two modes. I'm like, I think I'm done. I just gotta focus. Siri, stop talking. Good, turn Siri on. And why is the mouse not working? Yay. Everything sucks.
One zero four five six P. The internal method of a typed array.
Alright, I get this done.
A property key and returns a normal completion containing a boolean. It performs the following steps when called if P is a string. Then, a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I if is valid integer index. O, numeric index, is false. Return true, else return false too. Return. Ordinary delete. O, P, 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O XEST. Let keys be a new empty list. If is typed array out of bounds, tar record is false. Then a let length be typed array length, tar record be for each integer I such that 0I length in ascending order. Do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to key 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order, sexest or unordered, and returns a typed array with buffer witness record. It performs the following steps when called let buffer be obj if is detached buffer, buffer is true. Then a let byte length be detached, field name, value, meaning, object. A typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, and non-negative integer or detached, the byte length of the objects when the record was created. ECMA International 2024 197. 3. else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record, obj, byte length, 0, 4, 5, 1, 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays.
Alright, so I got like free.
Let internal slots
What's in freaking memory?
object, internal slots list, set A is specified in 1, 0, 4, 5, 1, set A is specified in 1, 0, 4, 5, 2, set A is specified in 1, 0, 4, 5, 3, set A, set A, set A,
Simultaneous memory.
4, 5, 6, set A is specified in 1,
I think this is done.
5, 7, 0, set A to prototype, 1, return A, 0, 4, 5, 1, 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called. If is typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size, 0, 4, 5, 1, 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array.
Okay, these ones can't be a pointer
Let O be tar.
because they're not close enough.
Return O. Assert is fixed length array buffer. O is false. Let byte off
Hold the pointer.
element size be typed array element size. O, let byte length be tar record. Assert byte length is not detached. Return floor. Byte length, byte offset, element size, 0, 4, 5, 1, 3 is typed array out of bounds. Tar record. The abstract operation is
Finally built.
argument tar record, a typed array with buffer witness record.
What else does this?
It checks if any properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert is detached buffer. O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid int. Edger index takes arguments O
I think it's saved.
and index a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F,
But is it working? Boom, boom, boom.
I, T, N, E, S, O, unordered. Note: bounds checking if
I hope it's working.
when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record.
Let's make a third call.
False. Let
Please let this be it.
tar record if
Pretty please.
0 or R.
The freaking cherry on top.
False. 0, 4, 5, 1, 5 typed array get element O in
It's only UN16.
typed array a get element takes arguments so a typed array and index
That makes it easier.
returns a number, a big int.
Set up whatever.
It performs the following steps when called if is valid integer index. O index is false.
I think it's working.
BO let element size be typed array element size. O let byte index
I would assume it's working.
index element size.
The stat field is 3, meaning both sets were set.
Typed array element type.
Wait.
You from buffer.
I can use my super fancy
Element
debug stuff now.
unordered 0, 4, 5, 1, 6 typed array set element. O index value. The abstract operation typed array set element takes arguments so a typed array index a number and value and
What the hell is up with the clipboard?
and returns either a normal completion containing unused or a throw completion. It performs the following steps when called if O is bigent, let num
Alright, so status field. I can print that as binary.
wise
I think it's Y.
to a number, value if is valid integer. Index is
Oh man,
set BO, B let element size be typed array element
I didn't make that one yet.
C let byte in
Crap.
index element size plus offset. D let element type be typed array element type. O E perform set value in buffer. O byte index in buffer. Element type num value true. Unordered return unused. ECMA International 2024 199 10 4 5 17 is array buffer view out of bounds. O the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called if O has their internal slot. Then, A let view record B, capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy F.
What the hell is this?
View out of bounds. View record. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T.
Oh my god.
O, sexy ST, return is typed array out of bounds. Tar record 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings X, ported from an ECMA script module. C16, 2, 3. There is a one-to-one correspondence between the string keydone properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value done property key is the string value of the corresponding exported binding name. These are the
For fuck's sake.
namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module. A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using a undefined as compare f 1 0 4 6 1. The internal method of a mod
Why did I put a loop there?
object takes no arguments and returns a normal completion containing null. It performs the following steps when called return null 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer 1 0 4 6 2 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called 1. Return set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called return true 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary get own property O p. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor value true, true, false 0 4 6 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary define own property O p. Desk. Let current be O p. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has a field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value. Desk. Current. Return true. 0 4 6 7 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if p is a symbol. Return ordinary has property O p. Let exports be O. If exports contains p, return true, return false. ECMA International 2004 201 10 4 6 8. The if p is a symbol, then a return ordinary get O p. Receiver. Let exports be O. If exports does not contain p, return undefined. Let m be O. Let binding be m resolve export p. Assert binding is a resolved binding record. Let target module be binding. Assert target module is not undefined. If binding is namespace, then a return get module name.
Well, it took too long.
0.
I think this might be working.
Target module 1. If target env is empty, throw a reference error exception. 2. Return target env get by.
So enters with not the bits not set, then they're set.
6. 9. It performs the following steps when called return false ones.
This is first allocation.
1.
Same as the second entry.
Method of a module name.
Third entry, this one triggers a new one.
A property key, and returns a normal completion containing a boolean.
Which means, on the third entry, 2 is being assigned.
Symbol, then a return.
After it's been translated.
Let exports be O. If exports contain.
Then a re-entry.
Return false. Return true. 0.
3 is going to be assigned.
1 1.
4 5. Then I'll double again. 6 is 12.
And returns a normal completion contain.
I think everything works.
It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104
I gotta save it back up
namespace
and try to finish this up then.
exports. The abstract operation module namespace create takes arguments module. A module
Or as much as I can for a bit.
strings.
Just know I'm gonna get it completely done.
It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let M be make basic object. Internal slots list. Set M's essential internal methods to the definitions specified in 10.4.6. Set M to module. Let sorted exports be a list whose element
If I can get like a speed boost
the same
out
value
of the old computers
and array
and the new ones,
finders compare F and set
that'd be awesome.
create own properties of them corresponding to
And some water.
28.3. Set module to M 0. Return M 0. 4. 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return. Set immutable prototype. O. V10 4 7 to set immutable prototype. O. V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value, V, current, is true. Return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called. The value of is an object, called the proxy's handler object, or null. Methods, see table 34. Of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments, and in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. Proxy handler methods, internal method, handler method, get prototype of, set prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has property, get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. 04. Copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, get prototype of if trap is undefined. Then a return target, let handler prota be. Call trap handler target if handler prota is not an object and handler prota is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler prota 1. Let target prota be target 2. If same value, handler prota target prota is false, throw a type error exception. 3. Return handler prota 0, 5, 2, V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, set prototype of if trap is undefined. Then a return target V, let boolean trap result be to boolean. Call trap handler target V. If boolean trap result is false, return false. Let extensible target be. Is extensible target 0. If extensible target is true, return true 1. Let target prota be target 2. If same value, V, target prota, is false, throw a type error exception. 3. Return true. Note the proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note the proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, is extensible if trap is undefined. Then a return is extensible target, let boolean trap result be to boolean. Call trap handler target, let target result be. Is extensible target. If boolean trap result is not target result, throw a type error exception. 0. Return boolean trap result. 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions if trap is undefined. Then, a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true. Then, a let extensible target be. Is extensible. Target. B if extensible target is true. Throw a type error exception. Return boolean trap result. 0, 5, 5, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Method, handler, get own property descriptor if trap is undefined. Then, a return target P, let trap result TOBJB. Call, trap, handler, target, P, if trap result OBJ is not an object and trap result OBJ is not undefined. Throw a type error exception. Let target desk be target P, 0. If trap result OBJ is undefined. Then, A if target desk is undefined. Return undefined. B if target desk is false. Throw a type error exception. C let extensible target be. Is extensible. Target. D if extensible target is false. Throw a type error exception. E returned undefined. 1. Let extensible target be. Is extensible. Target. 2. Let result desk be. To property descriptor. Trap result OBJ. 3. Perform complete property descriptor. Result desk. 4. Let valid be is compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false. Throw a type error exception. 6. If result desk is false. Then, A if target desk is undefined or target desk is true. Then I throw a type error exception. B if result desk has a field and result desk is false. Then, I assert. Target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as a known property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, P. Desk. The internal method of a proxy exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property if trap is undefined. Then, a return target P. Desk. Let desk OBJ be from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk OBJ if boolean trap result is false. Return false. 0. Let target desk be target P. ECMA International 2024 207 11. Let extensible target be is extensible target 2. If desk has a comma field and desk is false, then a let setting config false be true 13. Else a let setting config false be false 4. If target desk is undefined, then a if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else a if is compatible property descriptor extensible target desk is false, throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor target desk is true, target desk is false, and target desk is true, then I if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined. Then a return target P. Let Boolean trap result be to Boolean. Call trap. Handler target P. If Boolean trap result is false, then a let target desk be target P. B if target desk is not undefined, then I if target desk is false, throw a type error exception. 2. Let extensible target be is extensible target 3. If extensible target is false, throw a type error exception. Return Boolean trap result. 08 ECMA International 2024. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8 the language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler get. If trap is undefined, then a return target. Let trap result be. Call trap. Handler target P. Receiver. Let target desk be target P. If target desk is not undefined and target desk is false, then a if is data descriptor target desk is true and target desk is false, then I if same value trap result target desk is false, throw a type error exception. B if is accessor descriptor target desk is true and target desk 0, return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is an unwritable, non-configurable owned data property. The value reported for a property must be undefined if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 9 the perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call trap. Handler target P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target P. 0, If target desk is not undefined and target desk is false, then ECMA International 2024 209, A if is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk, 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property, cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property if trap is undefined. Then, a return target P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys.
So I don't know, I made a note. I gotta call this multiple times in a row to like expands again. It allocates from memory. It makes sure copied. And then that's done. Then I gotta add 2 more modes, the macro stuff. For like when an array needs to be assigned. But not like an item, like the thing as a whole. To pass it in the address, whatever. But not my base address, the address of like the collection that the thing holds. And then I guess 5 will be like a normal data array access. Or like you pass in the index instead of a source argument. And it's wrapped in parentheses instead of a block. It's basically all that's left. So, I don't know. I'm gonna try to finish this up. Get some water. I'm like, I don't want to like restart the Mac again. It's getting old. Still turning on. So like having to restart the Mac, it's getting old. I don't know. Alright, so I'm gonna do this for now. And then call it quits. And pick up tomorrow. Check that the location works. I don't know. Adding to the macro. That's to be a whole process. Everything's working right now. Theoretically, I'm gonna check to make sure. I don't want to break anything. I want to have everything in a working state. So I'm gonna pick up again to work on it. I don't have to like start off with stuff not working. Just like whatever. Alright, this is being called twice. This is the wrong one. This is foobar. This one. and the keyboard and mouse input, they like degrade over time on Linux. I don't know what's going on, but it gets worse and worse and worse, and it's not. I gotta restart this computer. I restarted the Mac. I'm tired of restarting computers because they don't work. The people that write the programs, software, they need to be restarted. Hard reset. Push the reset button. You know, the one button that everyone has. That button. Just give it a push. It'll reset them. And then they'll write better programs. Or they'll like enjoy it and not actually write better programs. Then they'll just be like button pushers. Never mind. That's the kind of button you don't want to push. So it prints the same address twice because it has two allocations and then uses it twice. But why is there a new line with this one? Why is this printing a new line? There's no new line formatter. So oh, here. Found the culprit. This is so boring. I want to be done. I need need to be done. I can't take this anymore. I want to be writing assembly. Not writing in C. C language sucks just as bad as C++. Two, 4, 9. That's slightly more readable. So it's from here to here. Zero. Print that as hexes. Three F80. Three F. Here, finally. So next would be 3F830. To the next location. C, D, E, F. And this is the next allocation. Shows up here. So it's call 1, call 2, call 3. It doesn't trigger the copy until call 1, and then call 2 are complete. This is call 1. This is call 2. Call 3 triggered it to resize. This is call 3. So the 2 got incremented to 3, then multiplied by 2 to make 6. So now it's resized. It's a bigger size. It doesn't have to be a power of 2, it's whatever. I want to multiply and do everything like based on the state of the numbers. Because if something's like deleted for some reason or removed from the list, it'll mess with that last thing. So if it's like set up where the control flow determines the numbers, whatever. I don't know, whatever. So I have like increment, then multiply by 2, then increment, then multiply by 2. Instead of testing a conditional and setting 1 and then multiplying by 2 only on the other entries, whatever. I want to do like the same number of operations every time. So if I like remove something or do something funky to the list, it'll be easier to repeat the correct operations. If I have a boolean or like a conditional, it's easier to possibly mess it up. So it's more like a clock or whatever, where it enters, it does its steps, and there's no like conditional flow, whatever, with the data. It just enters, increments, shifts, enters, increments, shifts. Not enter, testing condition, do this, do that. Alright, so it's called 3 times now. So I want to call it 3 more times to trigger the next resize. So I'll call 4 times to get the next resize and the one after it. And if the addresses look okay, then this will be done. And it's like for sure fine, it's working. I can finally get to this, whatever, tomorrow. Pick up from here on that. And when this stuff is done, the freaking array stuff, then I can finally start attaching it and replacing all of the vectors, because there's so many vectors. There's like 48 of them, maybe. Oh, it's gonna take an hour too. Dang it. Yeah, I'm not gonna start a whole new thing. Finish up this thing, and then pick up tomorrow. Alright, so we're gonna make 4 more calls. To trip the 6th, the 6th, the 6th, the 6th, yeah, whatever. I don't even have a lisp. Oh my god, do I have a lisp? No, I don't. I bit my tongue. Again. This time it doesn't even hurt. I bit it so freaking hard. An accident. I think I lost feeling on my tongue. Or I'm be in a lot of pain tomorrow. That's what I'm expecting. I think it's just it's numb. And then tomorrow I'm gonna be like, oh fuck, my tongue hurts. That's what's gonna happen. So at least it doesn't hurt right now. That's nice. It's 1, 2, 3, 4. Alright, please just work. I didn't get a core dump. It doesn't say core dump. So I think I'm okay. Okay, so first address twice. Just appear here. The count is 1. First entry, second entry, third, resize, fourth, fifth, sixth entry, seventh entry. So 6 didn't trigger the resize. 7 did, because that's when it entered as 6. It's got this address. Which is being assigned to this address. And in this address, it's here, 5, 6, triggers resize. So it should be copying from this address to the new one. And it is copying from here over to here for all 6. So this is 7, that's correct. This address should be the base whatever's copied to. Alright, everything works. It's been like a month. And I finally wrote a whole C thing with it running on first try. Well, like, there were other parts that got stuck. But like the main part, this part, finally. Now I just gotta get to the standard. And then go through from page 1 to page 816 without any mistakes. If I could do that with 0 mistakes, save so much time. So this program right now, the shading program, it's kind of like training wheels. I'm getting back into C, so I gotta figure it out. And I think I'm picking it up good. So eventually, I'll be able to write a bunch of code and just have it run all the time. I'm still trying to like figure out the last couple of kinks or whatever. I don't know, I think that's it for now. I still gotta test this stuff. There's way too much scrolling. I'll test this tomorrow. I don't know, that's it for now, I guess. So let the stream run on for 10 more minutes, because it doesn't always end the whole stream. So if I let the stream run on for 10 more minutes, it might send the whole stream, who knows. So I don't know, whatever. Next stream, hasta vista, peace. And the sound, oh, I can just highlight it, I guess. I did restart, so it might be working. But who needs sound, anyways? Sound is like so overrated. Just like 64-bit. Everyone's happy with 32-bit in web design. Why would anybody want a 64-bit JavaScript engine? Who would want that? Big numbers, those don't count. Those are like extended onto language. Because they didn't fucking update it from 32-bit. So I don't know, whatever. Peace.
At Valby arguments list.
I think this sounds working.
E perform. Create data property or throw. OBJ. to string, index, val, c set index to index plus 1, perform, define property or throw, obj, at iterator, property descriptor, percent array prototype values percent, true, false, true, perform, define property or throw, obj, callee, property descriptor, percent throw type error percent, false, false, return obj, 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0, 4, 4, 1. Set obj as specified in 1 0, 4, 4, 2. Set obj, set obj, set obj as specified in 1 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create, null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While index, len, a let val be arguments list, index, b perform. Create data property or throw, obj, to string, index, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true. 7. Let mapped names be a new empty list. 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If mapped names does not contain name, then I append name to mapped names. 2. If index, len, then let G be make arggetter, name, env. Let P be make argsetter, name, env. Perform map. To string, index, property descriptor, get, G, false, true. Set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, percent array prototype values percent, true, false, true. 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true. 2. Return obj, 0, 4, 4, 7, 1 make arggetter, name, env. The abstract operation make argget, takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note. Getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make argsetter, name, env. The abstract operation make argsetter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name in env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note. Setter is never directly accessible to ECMA script code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called if P is a string. Then, A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I let value be typed array a get element, O, numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. Return ordinary get own property, O, P. ECMA International 2024 195 10 4 5 2 P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if P is a string. Then, A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Return is valid integer index, O, numeric index. Return ordinary has property, O, P. 0, 4, 5, 3. P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if P is a string. Then, A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I if is valid integer index, O, numeric index, is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V if desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element, O, numeric index, desk. 7. Return true. Return ordinary define own property, O, P. Desk. 0, 4, 5, 4. The if P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I return typed array a get element, O, numeric